to these examples. Okay, similarly, the example to calculate the IHD. So we have, according to the formula, we have 1, 2, 3, 4, 5 carbon atoms. All right, and these carbon atoms, it will be written as 2 into 5 plus 2, and 6 is hydrogens out, because on this point there are two hydrogens, one hydrogen, because there's a double bond. Carbon makes 4 bond, we know that. There's one hydrogen, and there are no hydrogens on this carbon, because a double bond and 1 and 2, there are 4 bonds complete of this carbon. So there are overall 6 hydrogens and 5 carbons. So when we solve this formula, we get 3. So it means that the IHD for this is 3. So how it is justified? There's a double bond, and there's a ring structure, and there's another double bond. So 2 double bonds and ring structure make it a 3 IHD. All right. Then all right. Similarly, in the B example, a question, we have a straight chain structure, and in second and third carbon we can see I've highlighted this part that there will be a double bond, because when we see the valency of carbon, there a single hydrogen is dashed, and so it has a deficiency of 2 hydrogens. All right, so there will be a double bond over here, and when we calculate the IHD, 2 into 6 will be the carbon atoms, plus 2 and minus y here is 10. How? 2, 3, 4, 5, 6, 7, 7 plus 3 is 10 hydrogens. And when we solve it, we have 2 what we say, IHD. So how this will be, there will be a double bond over here also, and there will be a double bond over here also. The 2 double bonds will be formed. All right, on this on these last 2 carbons, and on second and third carbon. And now in the third example, there is a nitrogen atom. First we have to calculate the number of carbon atoms. So in these all carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 carbon atoms plus 2, and we have 17 hydrogens. 5 here, 6, 7, 8, 9, 10, 11, 12, 13. Over here we have 12. This is one hydrogen will be forming bond over here, so that will be removed, and there are 5 hydrogens. 1, 2, 3, 4, 5, because we know if benzene has C6H6 carbons and hydrogens C6H6, so here a bond is formed, so it will be C6H5, so there will be 17 hydrogens. When we solve this, we get 9, and this plus 1 is basically we are adding because of nitrogen. When one nitrogen is present, we add. So, there's one nitrogen, so we'll add plus 1 in this formula. So 1 nitrogen is present over here, so we'll add plus 1 over here, and we get 10 by 2 is equals to 5. So how 5 is here? There are 2 ring structures, 1 each, and 3 double bonds are present. So each double bond is having 1 IHD, so 3 plus 2 is equals to 5. So we have 5 IHD. Alright, now the third one, we know that oxygen has no effect on the IHDs. So oxygen silver atom, they're not considered in the structure. In the previous example, the first question, we also had a ketone, a cyclic ketone, and we did not have any effect on the IHD. So oxygen is not considered, but we have chlorine over here. Chlorine, I have discussed earlier that chlorine is considered as hydrogens, or like chlorine, bromine, iodine, these halogens, they are considered as hydrogens. So on the formula, this is 3 carbon atoms are present, 1, 2, and 3, and 5 is basically the hydrogens, 2 plus 3, 5, and plus 1 is basically this chlorine. Chlorine is being added as hydrogen, additional hydrogen. So when we calculate this, we have 1 IHD. 1 IHD means that we have a one double bond over here. All right. Similarly, in the last example, the E1, we also have, when you calculate the number of carbon atoms, there are 1, 2, 3, 4, 5 carbon atoms plus 2 minus 6. So 6 are hydrogen, 3 plus 3, 6. And when we solve this, oxygen has no effect. And when we solve this, this will be 3. And it means that 3 means that there will be a triple bond having IHD of 2 and C double bond O is also present. Alright, this C double bond O is having one IHD, a double bond, and a triple bond is equivalent to 3. So yeah, that's all for IHDs. I hope it's clear to you, and this is basically an important technique to in mass spectrometry to calculate the structure of the compound, whether we have any sort of unsaturation or not.